your key involvements, right? Now, in this case, when carbon is asked to gain four electrons, which is, will be requiring a lot of energy. Similar is the case with the four electrons loss. Now, what carbon has to do? It just thought of doing something midway between the two, and that was the sharing, right? And this came up with the concept of sharing of electrons, which means that it is showing us covalency of 4, right? And sometimes we write this as tetracovalency. Okay, so tetra means 4. You must have read on that juice packing or milk packing, tetra pack. So that means there is 4 layer of packing. So here also tetra means it is going to share 4 electrons at one time. Okay. Covalency, co means you are sharing, right? And valency is the tendency to combine. Okay. Now, the next property. This is fine, but this property is also shown by silicon, which also has, valency of 4. So what's unique about that? There is something unique. So uniqueness is its self-linking property. What's that? It's called catenation, right? Now, carbon has got a tendency to attach with itself in any manner, right? It can attach like this, or it can attach like this, right? Or if it wants to, it can attach like this. So there are innumerable ways in which a carbon can attach with itself to form long chains of compounds. And you would believe all these compounds can be named by us. That's the most fascinating thing, right? If I'm writing something, I can name that. Okay. So this property is catenation. And you would believe this property is also shown by silicon. But we do not study silicon chemistry. Thank God, right? Otherwise, one more subject would have been added. Now, why silicon chemistry is not there? Because when silicon, it shows catenation, the products which are formed, the compounds which are formed, they are highly unstable. Okay, the unstable compounds are formed. So that means the compound cannot sustain for a longer time. So we cannot study its properties. So thus we are only, blessed to have only organic chemistry as to study when we are talking about carbon. So this is a very common question being asked in the examinations: ki why so many compounds of carbon are found? So you can write up 3 reasons for that. One is your tetravalency, right? Tetracovalency. Number 2 is your catenation. And number 3 is your small size of carbon. Okay. The size of carbon is small because atomic number is just 6, right? It has got only 2 shells. So naturally, its atomic size is a little bit less. Now, whenever I teach this subject, the students have this thing in mind. Array, like now we are to stuck in. Why so many compounds and we have to study each and every compound's properties? Oh, we are stuck in. We have taken the wrong branch. No, carbon is doing a favor on us at this moment. What kind of favor? See, when carbon forms compounds now, the kind of similar compounds they are formed, they are grouped into one particular type of category of compounds. And you would believe that category of compounds now, it has got the same chemical properties. It can be prepared by the same methods of preparation. And this gives us a lot of relief. For example, I'll tell you one thing. Uh, you must have heard of alkanes,
Yeah.
hydrocarbons. Yeah. So, just a second, let me wipe off the thing so that we are clear with the things. Okay, I'm talking about hydrocarbons. Hydrocarbons means the compounds which are there with the carbon and hydrogen as the main participating elements, right? Okay. Now, hydrocarbons, they are of 3 types. Okay. Number 1 is your alkanes. Now, when I'm saying alkanes, so all the compounds which are having single bond between carbon and carbon, they'll be in this category. Okay. Or in a more scientific manner, what I should say, the compounds which have got the same journal formula, which is CnH2n plus 2. This is the formula which represents our class of alkanes. If I want to ask na ki if carbon 15 is there, so what will be the formula of the alkane? It's very easy for me. C15 and H32. I have named the compound, right? It's there in my hands. So it becomes so easy. You must have done arithmetic progression in mathematics till now, if I'm not wrong.
Yeah.
Yeah, right? So it's just like that. See, now the first compound in case of alkanes will be, obviously, when I'll put N is equal to 1, right? So this becomes CH4, which is methane. And the next becomes C2H6. Now, if you see the difference in the number of carbon and hydrogen atom, it remains same, which is CH2. So every succeeding member of that particular category will differ by CH2 from the preceding one. You got my point?
Yeah.
Yep. What did I say? What
So
was,
like
yeah, what was
yeah,
this CH2?
like it if you basically like add it on and it just keeps going like that. Like
Ah, yes.
C3H8. No,
That's
yeah,
correct.
eight.
That's super. So, if I see, na, the atomic mass of carbon is 12 and hydrogen is 1. 1 into 2 becomes 2. So, it becomes 14 AMU. So, there is a difference of 14 AMU in the mass units of the succeeding members. Okay. In this way, we can also say the thing. So, the category of compounds which can be represented by the same journal formula and they differ by CH2 group, or we can say 14 AMU mass unit. So that category of compounds is termed as homologous series. Okay, this is homologous series. And homologous series, the most characteristic property of homologous series is that they are represented by the same journal formula. Okay, same journal formula, and they have got the same chemical properties. Like for example, all alkanes, they'll be having the single bond between carbon and carbon, right? Leading to saturated hydrocarbons, right? They are saturated hydrocarbons, and the kind of reactions they are going to be like showing up, that will be substitution reactions. That means the kind of reaction will remain the same, right? The method of preparation for methane, ethane, propane, they are going to remain the same, right? The next category of hydrocarbons is your alkenes, okay? And the third category is your alkynes, okay? Now, alkenes, they are represented by the journal formula CnH2n. And whenever you have a organic compound having ene in it, okay, this means that there should be a double bond between carbon and carbon. Now, here's one point to be noted. This was a doubt which one of my students asked about that, and it was a very good doubt. What was the doubt? As I'm telling you that there should be a double bond in the like two carbon atoms, right? I'm writing a compound like this. Now he was like worried कि ma'am whether this chain will be called as the saturated or the unsaturated. What do you say?
Um,
This one is
saturated.
sorry,
Saturated.
saturated. And how? Why did you say that? Like, what's the reason in your mind?
I'm not sure.
Okay, no issues. Whatever came to your mind, you have to share it with me. Or it was just
Yes.
a guess.
Guess. Yeah, just a guess.
Done. See, up saturated, the word comes up कि we have the single bond, right? I can see two single bonds. But if there is a presence of a double bond, this is called double bond. Okay. If this is the case, then it has to be alkene. Okay.
Yeah.
Only single double bond will make that compound applicable to be called as alkene. Got it? If in case I have a compound like this, okay, there is one triple bond, okay, so that compound is categorized to be called as alkynes, and its journal formula is CnH2n minus 2. Okay. Acha, okay, let me show you how it is like sharing. You have that idea in your mind how carbon is going to share electrons, or should I show you? I think you don't have that in your mind.
like by losing and gaining like that.
Yeah, like see, this is carbon. It has got four valence electrons. Okay. Now hydrogen has got a single electron in its valence shell, right? Atomic number is 1, right? Now this hydrogen is going to fulfill its duplet because it has only one electron. So if it is going to have one more electron, it is more than happy, right? It is saying now my valence shell is complete. I am stable, right? And
Yeah,
now as carbon has helped hydrogen, each of the hydrogen to complete its shell, now it's turn for carbon. See, now in its valence shell, carbon has how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. And that was the requirement, right? The 8
yeah,
electrons are to be there in the valence shell. So this is called sharing. Now see,
yeah,
I have taken only single carbon, right? And there is always a single bond between carbon and hydrogen. Okay. Can you give me that
yeah.
reason behind that? Why there is a single bond between carbon and hydrogen? I just said the statement. Actually,
Oh,
that's what I'm asking. How many electrons has
because
hydrogen in its valence shell?
one,
One. So how can it make more than one bond? It cannot because it doesn't have. Suppose you are bowling to the like opposing team, and out of that over, only one ball is left. So you are going to bowl only one ball, na? How can you
yeah,
bowl out three balls more? No, you cannot, right? So hydrogen has got only one valence shell, therefore one electron, right? So that is the reason why it is forming only single bond. Now, if I'm talking about carbon, there are two carbons involved, right? So what I'm going to show you, like it has got four valence electrons. Similarly, this carbon has also four electrons. Okay, now again, hydrogen will be there. So hydrogen to bhai, it is going to form only single bond. So we are going to fulfill the single bond. This is done. Okay. Now it's the turn for your carbon to complete its valence shell. Now how it is going to do? Just see. Now carbon is going to ask hydrogen because carbon helped hydrogen to complete its valence shell. So hydrogen is more than happy to help that, right? Now, if I'm talking about the carbon which is present on the left side, see, 1, 2, 3, 4, 5, 6. Still, there are two more electrons required. Got it? Just see, 1, 2, 3, 4, 5, 6. Two more electrons are required. Now, what this carbon is going to do? It is going to ask its neighboring carbon to help. Got my point? Now,
yeah,
how it is going to help? It is going to take these two electrons in its sharing cloud. Got it?
yeah,
Now count the electrons 1, 2, 3, 4, 5, 6, 7, 8. And its valence shell is complete. Similar
yeah,
will be with this carbon, right? It is going to take these two electrons in its shared cloud. Now, if you
yeah,
see, this is the overlapped cloud, right? Which is being shared by both the carbons. So it has one shared pair of electron and another shared pair of electron. So this type is known as your double bond. Is that clear?
yeah,
Yeah. Got the thing in your mind now? Same is with
yeah,
the triple bond. In case of triple bond, now what happens? The two carbons are going to share three pair of electrons with each other. Right? Now, if I count the electrons, there are six. Two more are required, and that carbon will take help from hydrogen. Okay, so this is the same. Now, see, hydrogen, though, it is going to, fatavat se, it is going to complete its duplet. Now, it is quickly, okay. Now, this carbon is going to ask for help from the adjoining carbon. This again, now the shared pair, the cloud which is, common to both the carbons, it has got three shared pair of electrons, right? And it is forming a triple bond. Is that clear? Yeah.
yeah,
So these alkanes, now, they are your saturated hydrocarbons and alkenes and alkynes, they are our unsaturated hydrocarbons. You know what? Hydrocarbons which are unsaturated, they are very reactive in nature. They are reactive in nature. Saturated ones, they are quite satisfied with their state of the compound which is there, right? But
Yeah.
unsaturated ones, na, they'll keep on, reacting with other elements. So it's very fascinating to see that. Okay, I hope this concept is clear to you. The homologous series is clear to you, right? So homologous
Yeah.
series, na, it has got so many compounds, so many compounds. See, if I talk about alkanes, so I have taken unlimited alkanes in that. I just need to have the journal formula. That's it. I can frame up any number of alkanes, right? Same as with this alkenes. This is again has got the same journal formula. Alkynes, again, it has got the same journal formula, right? Similarly,
Yeah.
there are so many classes of compounds of carbon, right? Like, for example, alcohols are there, then ethers are there, ketones are there, aldehydes are there. So, slowly, we are going to study about that also, because organic chemistry is something which is it's a very huge topic. It's not a very easy one, but yes, but it's very interesting. Okay, so
Yeah.
Abhi, we are going to proceed on with a little bit of nomenclature.
On?
You have heard this statement, nomenclature?
No.
No. Okay, I'll let you know. Nomenclature is something which we say we are going to name the organic compound. Okay, we are going to name the organic compound. For example, I am writing uh, this. Okay, this is a chain. Now, how many carbon are there? One, two, three. When three carbons are there, now I am going to write prop, right? And if there are single bonds, then I'm going to write in with this. I know this topic is now a little bit too vast to start, the things. But I hope you're clear with the hydrocarbon part, homologous series part, right?
Yeah. Yeah.
Okay. See, देखो, I told you in the starting of the lecture that carbon forms self-linking chains of compounds, right? It is going to form. And we cannot mug up names of everything, but we need to frame up the names. That scientific category of framing up of the names of organic compounds is termed as nomenclature, and it is governed by IUPAC, right? It gives us some rules and we have to follow those rules. We cannot go against those rules, right? Otherwise, in all over the world, like I'm, teaching from India and you are studying from somewhere else. So if I'm talking about propane, so everywhere in the world, every chemistry student, every chemistry teacher is going to make the structure like this.
Yeah.
Got it? So this is to bring the uniformity in the naming. Otherwise, what will happen? I'll pronounce the things, I'll make the things as in my country, right? And you are going to do the things in the in your country. But when we are going to collaborate, then it will be a problem. I'll say something
Yeah.
else, you will understand something else. So that becomes a problem, right? The chemical cannot speak up, na? And now propane cannot speak up. Hey, I am with three
Yeah.
carbon atoms. It cannot speak
Yeah.
up, right? So we need to
Yeah.
be very much clear about the rules. Rules are a little bit confusing, but when you practice them, na, they are going to be very much easier to follow. See, I'm not going
Yeah.
in for the rules today because I'm not aware of your syllabus. Actually, you're going to send me the syllabus so that I can frame up the classes for you, right? It
Yeah.
was just a demo class, just an introduction to the organic chemistry, and I hope you
Yeah.
have understood the thing, right?
Yeah.
Yeah. Otherwise, as a teacher, I don't believe in one class scenario, because every time a student and a teacher has to be very comfortable with each other. Because whatever I'm
Yeah.
saying, it should be understandable to you. And secondly, whatever is going on in your mind, the doubts, the things, that should be communicated to me. Okay. If
Yeah.
you're continuing, then please do keep in mind that doubts are to be asked, right? They are
Yeah.
not to be kept in mind, right?
Yeah.
Otherwise, there is no use of learning, right?
Yeah.
So that you have to remember, and all the very best for your next things, right? Chalo,
Yeah.
see you.
Okay.
Okay,
Thank you.
bye. Bye bye.
Bye.